Good afternoon, everyone, and welcome. I'm Cheryl Reynolds, and I'm with the UC Statewide IPM program, and welcome to today's UC Ag Expert Talk on California Red Scale. Peter Crisina is also here with me, and he'll be running our polls and doing any troubleshooting. And please note that the webinar is targeted to growers and pest management professionals. Master gardeners can certainly benefit from participating, but the pest management methods presented, especially the pesticides, are not to be followed without a clear understanding of their legal use by homeowners. And so now I'd like to introduce our speaker for today. Dr. Beth Grafton-Cardwell is a citrus IPM specialist and research entomologist. And today she's speaking from the Lindcove Research and Extension Center on California Red Scale. And so now, Beth, I'll pass this over to you and you can go ahead and share your slides.
Okay, I'm going to talk to you today about California red scale and its natural enemies. And this is the super abbreviated version because I only get about 30-40 minutes to get through it. Tomorrow I'm going to be teaching a 6-hour course on this subject in which we look at California red scale and its parasites underneath microscopes and spend a lot of time learning the nitty-gritty details. Most of you know that California red scale causes both direct and cosmetic damage to citrus fruit. And so it's one of the top 4 pests, especially in the San Joaquin Valley, and it's necessary to control it. And one of the reasons that I teach a 6-hour course is that the life cycle is fairly complicated. You've got females that are doing one thing, sitting on the plant and molting and becoming bigger and bigger, and you've got males that are doing something else. They're molting and developing wings so that they can come and find the females. And so we have only 2 stages that are actually moving around that we can catch on traps, like crawlers and adult males. And then the insecticides and the parasites we release attack different stages. So if you understand the full biology of this organism, you can do a lot more towards monitoring it and evaluating it and controlling it. So that's my rationale for going into some detail about the life cycle. So basically you start with a gravid female. She doesn't look like much from the top, but if you flip her over in that middle picture, you can see that there are crawlers that emerge out of her pygidium. So you never see eggs, you just see crawlers. And those crawlers can walk, they can be blown by breezes, and there is even evidence of them riding on other insects. I don't have a picture of scale riding on other insects, but this picture on the right here is pretty cool. It shows broad mites riding on a whitefly, and you can see them just clinging to the legs of this whitefly. So we know some of that is going on as well, but probably most of the time they're just moving by, either crawling or floating through the air. Once the crawlers land, they insert their mouth part, which is like a little thread. It's very, very thin. They insert it into the leaf or twig or fruit, and they settle down and they start to produce what we call a white cap, which is really just wax produced out of their body. And they turn in a circle, and the wax is produced in a circle. So you see what we call white caps. So that first instar scale has a yellow body, which if you poked it would have liquid inside, and it has a waxy white cap over the top of it. And the white cap is for protection, and you can separate those two pretty easily. But most insects do what we call molting in order to get bigger, and scale are no exception. And so its first molt, what it does is, I'm going to advance to this picture and then I'll come back to it. What a molt does, molts are not feeding, and so they pull their mouth part out of the plant and they create this wax underneath as well as on top, and they become kind of like a clamshell. You can't separate them. And every time they molt, they're absorbing chitin into the cover that's over the top. Chitin is the structural stuff of insects that makes them hard. So instead of just having this pure waxy coating, they have wax plus chitin. And you can determine the stage of a scale by looking at instars and by looking at molts. You can tell what stage they are. For example, with this first molt, these are actually on the right side, you see there, these are 3 different scales. So 1 we're looking at from the top and 2 from the bottom. So no longer can you separate the lid from the body. It's all like a clamshell stuck together. But you can see the bottoms are now orangish, and that's because they're putting that chitin into the cap. So the reason we want to understand this is insect growth regulators prevent scales from molting, and so the treatments need to be applied while they're in that instar stage, not while they're molting. You want to get them before they molt. So that's the reason for understanding instars versus molts. So then they molt, and they go from that first molt into the second instar. So your picture on your left is the second instar. And I know it's a second instar 2 ways. I can look at the scale body, which is a teardrop shape, and I can also look at the lid, and my little arrows shifted over. They should be centered better. Anyway, the molt ring is that center part, and that's where the chitin has been added to the cap. And then the gray skirt is the excess part of the wax on the outside that it's adding to the lid. So that's a second instar. It's got 1 circle of chitin because it's molted once, and it's got a teardrop shaped body. Then that stage molts again in order to get bigger. And I know it's the second molt, so this is 2 scales, 1 viewed from the top and 1 viewed from the bottom. I know it's a molt because I can't separate the top from the bottom. It's larger than a first molt, and there's a circle of chitin in the middle of it, so I know it's already done 1 molt. So we're moving along. Now here's a third instar scale, and these are females. And this is the stage that the males mate with. And it's also the stage that a Fetus likes to lay its eggs on. A Fetus is the little natural enemy, the parasitic wasp. And I know this is a third instar female because it has lobes on the body. It's no longer teardropped. It's got these little lobes that hang down on either side. And if I look at the lid, and again, my arrows got pushed off a little bit. There's a gray skirt, and there are 2 rings, molt rings, 1 in the middle and 1 just on the outside. So that's how I can tell it's a third instar. It's molted twice, and the body shape has changed. So that's the female. The males do a little something different. They go through the first instar and this first molt and the second instar. But when they get to second instar, as they mature, if you look in box number 1, that is a second instar male scale, you can see they're developing eyes. They have to be able to find the females and fly around. So they're finding the females mostly by pheromones, but they're using their eyes, which probably only tell them sky versus ground. They're using their eyes just to navigate around among the trees and get to a citrus tree. So I know this is a male scale because it has eyes, and when you go from box 1 to box 2, they molt into what we call the prepupal stage, and then they molt again into the pupal stage. And I can tell that that's a pupa because you can see on the edges of it, it's starting to develop wing buds and an adiagus, which is basically the insect penis. And those things are more developed in the pupa than they are in the prepupa. And then it becomes an adult. With wings, which I'll show in a second. So what's the reason I'm showing you all these different stages? Who cares if it's a pupa, a prepupa, or a pupa? You need to understand that females are only molting twice. Remember, they do a first molt and a second molt. Males are molting 4 times. They're molting between the first and second instar. They're molting before they become a prepupa. They're molting before they become a pupa, and they're molting again to become an adult. So they're much more sensitive to chemicals like insect growth regulators that affect molting. So that's why you need to know these important facts about California red scale. So there's a male once it's molted, and the males fly to the third instar virgin females in order to mate. The females aren't going anywhere. Once they put their mouth part in, they are not moving from first instar to the day they die. They just sit in the same place. So the males insert their adiagus under the scale cover and mate with the females, and the beautiful thing about these male scales is they have a brown bar on their back that makes them really easy to recognize on a trap card. Then, once the female is mated, she becomes enclosed in wax again, and it's really hard for insecticides and parasites to attack her. So that's another important fact to know, is that female scale are hard to kill with insecticides or parasites. So again, you need to get control of the population before they get to that stage, whenever possible. So we can use this information about these different stages in order to trap the scale, and I'm going to go into that a little bit about pheromone traps and crawler tapes and things like that, which are all methods for understanding what's happening with the population. Pheromone cards you hang in trees with a little pheromone capsule lure above them. And these cards were designed many, many years ago. A lot of testing was done to figure out if they would attract the scales in a certain pattern. And then they figured out that instead of counting every scale on the card, they could put these squares on the card in a way that reveals the amount of scale on the card without having to count everything. So basically what you do with these cards is you count everything that's inside the squares and then multiply times 5, because the squares represent 20% of the card. Now, sometimes the cards are really heavily infested, like the one on the right, which makes it really difficult to count even what's in the squares. So what a lot of pest control advisors do is they'll take cards, like representative cards like this with different densities, and they will do a careful count and estimate how many scale are on that card, and then they'll save those cards as examples, and then in the future when they get a heavy one, they can just kind of hold it up and goes, well, it looks like the one that has 10,000 on it versus the one that has 5,000 or 2,000, and probably doesn't matter if it's 2,000 or 10,000. That's a lot of scales. And how can you use these pheromone cards? You can use them a couple different ways. A really important way is to hang them and then change them on a weekly basis so you can see when the male scales are flying. Generally speaking, the first male flight is in March, and the second male flight varies, depends on temperature, early June, mid-June, often around, I'm trying to think, no, that's the crawlers that go in May, but June or July. And then the third and fourth generation, you can no longer see peaks and valleys because you got so many stages on the tree and they're all overlapping, it's really hard to see. But generally there's 3 or 4 more generations. With the crawler tapes, most people don't do this, but we do it because we like to understand when the crawlers are crawling so we can run pesticide trials. We use double sticky tape, just wrap it around a branch near a female scale, and then change it weekly. You unwrap the tape, put it on an index card, and then you look along the very edge of the tape for the crawlers. And you can replace those once a week. And from this, we develop data like this where we can see, okay, the males flew and then the crawlers crawled and then the males flew and then the crawlers crawled, and we can be more accurate about when crawler activity is happening. The alternative, which many people do, is you track the first male flight, and from that you can predict all the rest of these events based on degree days, which is the accumulation of the average daily temperature above the lower developmental threshold for red scale, which is 53 degrees Fahrenheit. And I'll talk about that some more in a minute, about how you do that calculation. So there are about 550 degree days between events, for example, between male flight and crawler activity, and then another 550 to the next event, which would be the next male flight. So in these units of 550 degree days, you can predict just about everything that's happening with those scale throughout the season. It's more accurate to put out tapes and cards on a weekly basis, but for efficiency's sake, you can at least for each block get when that first male flight is, and then you can do a pretty good job of predicting what happens after that. So degree days, how does this work? Okay, springtime, your high might be 74, your low might be 50. So your average daily temperature is 74 plus 50 over 2, which is 62. And then you subtract the lower developmental threshold, which is 53, you get 9 degree days per day in the spring. So it's going to take about 60 days to accumulate that 550 degree days. So things happen slowly in the spring. Versus the summer, your high is 103, your low is 81. 103 plus 81 over 2 is 92, minus 53, the lower developmental threshold, you get 39 degree days. And so it only takes 15 days to accumulate the 550 degree days from male flight to crawler activity, or crawler activity to male flight. So things are happening slowly in the spring, taking a month or two, happening really fast in the summertime, especially in the last 8 years since we've had such high temperatures. So that's why degree days are really important. Insects develop based on temperature. If you really want to know what's going on with them, you've got to be monitoring degree days. So we're ready for the first set of questions that Peter is going to float up here. Okay, so the first question is, how many times does a female California red scale molt? 1, 2, or 3 times? Okay, 67% of you are correct. Females molt twice. Once between the first and second instar, and once between the second and third instar. The males molt 4 times. Okay, next question. How many degree days between a male flight and crawler emergence? 550, 1100, or 1650? 95% of you are correct. 550 degree days between male to crawler, crawler to male, male to crawler. 1100 would be between male to male or crawler to crawler. Okay, next question. When you count male scales in the squares on the pheromone card, what number do you multiply by to estimate the total number of scales on the card? 2, 5, 10, or 20? And 85% of you are correct. You multiply times 5. Okay, we're ready to go on. So let's talk red scale management. You have choices. I used to have Lore's ban as a choice, but we've lost the use of that. So we're down to 7, Esteem, Centaur, which used to be known as Applaud, Movento, Oils, and Fetus releases. Now each of these has their value. 7, most of them, actually all of them, I've rated as moderate in their efficacy. Nothing is what I would call super toxic to red scale. They all have issues. For example, 7 and Esteem have resistance issues. We have populations in the San Joaquin Valley that are resistant to those chemicals, and so they don't work fabulously, but they still are very helpful. What else do I want to say? Movento does not control scale on wood, so that's why I give it a moderate rating. It does pretty good on scale on leaves and fruit, but doesn't control the scale on wood, and that's kind of a problem. Oils are often used by the organic growers, and they have a very short residual, so oils will kill whatever they hit, but if they miss it, they miss it. And then the Aphitis, the effectiveness varies from year to year and situation to situation, so again, I call them moderate. In terms of selectivity, by that I mean how toxic are they to natural enemies? 7 is very toxic to most natural enemies. Esteem is pretty soft, and Centaur, except to the predatory beetles. So it can disrupt Vidalia beetle that feeds on cottony cushion scale. It can disrupt Rhizobius, which feeds on California red scale. So they can be a problem. But if timed carefully and used infrequently, I think that effect is minimal. Movento is in the group of insecticides that have mitocidal activity, so they're toxic to predatory mites, but it's not toxic to beetles or Aphitis, and so I consider it a pretty soft chemical. The oils will kill anything they hit, but the effect is so short term that most natural enemies can rebound pretty easily. And then Aphytis, of course, is non-toxic. In terms of spectrum of activity, a reason to choose 7 might be because you've got Citricola scale or fuller rose beetle in the block, and you need to take care of those at the same time. Esteem is pretty narrow. It's really only effective against red scale. Centaur is a little broader. It has some activity against Citricola scale. Movento, again, is pretty narrow. It will suppress thrips and it will affect mites, but it's pretty heavily used mostly for red scale. And then the oils will affect most pests that are on the tree. And the Aphytis is absolutely narrow. It only affects the California red scale. So when we're looking at the life cycle of California red scale, you can see that 7 and oil are going to be most toxic to the crawlers and whitecaps because they're tiny, and the whitecap is not very protective, and so you just get more kill if you're targeting the crawlers and the whitecaps. The Esteem and Centaur, you're trying to get the compound in during the whitecap stage before the insect goes into its molt, and that's how you prevent it from molting. And the two work differently. Esteem is a juvenile hormone mimic and doesn't let the insect have the right hormone balance to mature. And Centaur is a chitin synthesis inhibitor, so it's going to block the insect's ability to create that chitin that it needs for its strong structure. So you're trying to get the product in similar to 7 and oil early instars. Movento kills all stages, but mostly on the leaves and fruit, as we talked about. And the Aphytis really likes the 3rd instar females. It will attack 2nd instar males and females, but it prefers those 3rd instars. So when you look at your population of scale and you're thinking about when to use any of these treatments, the life cycle tells you a lot about when to apply these. Let's talk a little bit about Aphytis releases. What's done in the San Joaquin Valley is 5,000 wasps per acre every 2 weeks are released in every 6th tree and every 6th row from March through October to try and get 100,000 per acre for the entire season. And people say all the time, well, if I release more, will I get a better effect? Not necessarily. Or if I stop releasing in the summer, is that okay? Probably, because they're probably not as efficient in the summer, but more is better. You can't release a whole lot at once and expect them to do the job for the rest of the season, because what you're really trying to do is seed the orchard with a few Aphytis here and there constantly. So you're creating little mini insectaries in the orchard, and those will spread from there. You literally cannot release enough Aphytis to get to every scale in the orchard, so you're really trying to create insectaries. So to maximize that effect, you have to prune the interior and the skirts of the tree so the Aphytis can get to the scales. They like to work on fruit and leaves on the exterior of the tree. So if you open up the tree, you're going to get more of them into the inside. You've got to minimize broad spectrum insecticides by choosing careful timings and rates. You've got to avoid dust. Things like lime, sulfur, surround, and other coatings will prevent the parasites from reaching the scales. You've got to avoid water stress to the trees that promotes scales. Generally, larger orchards are easier to control biologically because the sprays of neighboring blocks have less influence, and you've got to reduce ants that protect scales from natural enemies. How do I know if a Aphytis is working if I'm releasing them? Well, it's pretty labor intensive, but you can count the number of fruit out of 100 that have scale, so you calculate your percentage of infested fruit. You can examine 2nd and 3rd instars and determine the percentage that are parasitized, and that's what I teach in the class tomorrow. And then parasitism, you should be able to see it increase during August through October. It's not so much the number of scale in the fruit that's important, it's how many are parasitized, because the parasitized ones flake off. So the pictures you see here are the same piece of fruit in August and September after parasitism has caused a lot of the scales to flake off. So if you see the parasitism progressing and you see a lot of flaking off and you don't see a lot of first instars being produced, you know that the parasitism is working. So this is an example of way back from 2001 and 2002 in Tulare County. The bottom 3 orchards, 4, 5, and 6, were treated with Lorsban, Supercide, or Esteem, and they had virtually no percentage of fruit infested with red scale, 0, 1, or 2%. You look at the Aphytis orchards, 1, 2, and 3, and you can see that they had upwards of 18% of the fruit had scale on them. And you might think, well, that's scary, but look, in October 2001 in Site 2, 86% of those scales were parasitized and flaking off. So as long as you're seeing that increase, that progression, and you have available high pressure washer to wash off the remaining scales, you should be fine. So it's getting the Aphytis in there and getting them to increase through that fall period that's critical. So we do a lot of pesticide screening just to understand how chemicals affect the different groups of beneficials. And let's just look at the parasite column there. You can see that OPs and carbamates, pyrethroids, neonics are all very, very toxic to the parasites. Esteem is soft. Excuse me, I'm going to cough for a second. Esteem is soft, so is Entrust, relatively. Delegate is surprisingly toxic to these parasites. But I think because for Delegate, you're applying it for thrips, mostly on the outside of the tree, it's not really affecting them very much. Centaur's pretty soft, Movento's pretty soft on the Aphytis. So these are things that show you what's compatible and what's not. And this information has been published in Citrograph, so it is available. And it's also in the UC IPM guidelines. So what about neonicotinoids like Admire, Actara, Platinum, and Assail? Some people think these are red scale materials, and they can suppress red scale, but they're very toxic to all natural enemy groups. The foliars are harsher than the systemics, but even the systemics will kill natural enemies. They tend to kill scales on the leaves and the fruit, but not the wood. So overuse of these types of chemicals leads to a buildup of scale on the wood, which eventually spills out onto the fruit. And that's where we've been having some problems in the past decade, I would say. So we're ready for the questions, the second group of questions. The first one is, how many Aphytis per acre should you release in the San Joaquin Valley? 30,000, 50,000, or 100,000? Okay, the correct answer is 100,000. In Southern California, people often release fewer. The climate is more suitable for Aphytis, and you can get away with that. But up here, it's pretty intensive. You've got to get up to that upper end. Next question. What stage is most easily killed by oil? The first instar, the molts, or the adult female? The answer is first instar. 85% of you got that correct. They are small and sensitive to most chemicals, but the oil especially is good on those. Next question. Which group of natural enemies are the insect growth regulators toxic to? The predatory mites, the parasitic wasps, or the predatory beetles? 60% of you are correct. The predatory beetles like Vidalia beetle and Rhizobius are especially sensitive to insect growth regulators. Predatory mites and parasitic wasps, you know, there's some effect on them, but not nearly as much. Okay, let's go on to the next part of the talk. When to spray? Okay, pest control advisors have traditionally used pheromone cards to watch populations on a weekly basis, or they put them out during the 4th flight, and if they got a lot of them on the card, then they say, okay, I got to take care of that orchard next year. The general rule of thumb was about 1,000 scales in the 4th flight. So that was sort of generally how people did it. But male scale pheromone lures and cards were developed for Lorsban, Supercide, and 7, and so they don't predict scale populations accurately with newer scale control methods. For example, sometimes there are no male scales on the pheromone cards, but there's a noticeable scale population in the block. That could be because an IGR was used, and remember, they're more toxic to the males than the females because they molt more often. Or you could be using pheromone disruption, which we're going to talk about in a few minutes. And the males can't find the trap cards. So when you're using those types of chemicals, you're just not going to see very many males on the cards. But you may or may not have a population in the block. Conversely, you might have really high levels of male scales on the pheromone cards after treatments, even though the fruit's pretty free of scale. What's going on there? Well, the aphitis prefers to attack female scales, and that lets a lot of the males survive. And so you might have a lot of males on cards, but the block looks really clean. And as I said, neonicotinoids and Movento keep the fruit pretty free of scale, but they allow populations to build up on the wood, and that could be producing plenty of males that are then found on the cards. So it might be that there is a population in there, and you're just not seeing it on the fruit. And sometimes applications are just made poorly. It doesn't reach the top of the trees, and there's a bunch of scale, and those males get on the pheromone cards, and it's a clue that you might have a serious population in there. So you can't just depend on pheromone cards. You've got to be checking leaves and twigs and wood for live scale. Is the scale just on the dusty roads, or is it throughout the orchard? You might have an edge effect just from stress of the trees. Look into the interior and the tops of the trees to see if scale is building there. And if it is, then you've got to improve the coverage you're getting with the insecticides. You can rub your thumb gently over the scales to see if they easily rub off and get to know what's a live versus a dead scale. I often have people bring me fruit or leaves that have lots of scale on them, and they're panicked, and I look at it and I go, it's all dead. So it's not going to be a problem. So learning live versus dead is really important. And 1 month after you put a treatment on, take samples back to your office and try and look at them closely with a hand lens or a microscope and see if they're healthy or parasitized. Are they producing crawlers? If not, maybe biocontrol or the insecticide are really working. You've got to walk the block and check fruit for live scale at harvest and check bins. If you find more than 5% of fruit infested, then the block likely needs a treatment. And then we've had factors over the past 8 years now that have caused California red scale to explode. We've had extremely warm winters, and for the first time ever, a couple years ago, I saw scales of all stages developing in the winter time. Crawlers were emerging in the winter, which we don't normally see. We've had drought with dusty, stressed trees, and the parasites don't work as well on those. We've had huge accumulation of heat. What I'm showing here in this graph, the dotted line is the 30-year average before 2012, and the lines below it are the degree day units accumulated in 2010 and 11, and those were years where temperatures were below normal, below average. Every year since 2012, the temperatures have been above average, and I show you here 2015 and 16, and then the current 2019. We started out in March, April, May with below average temperatures, but then things just started cranking, and we've been above average since about August. So if we continue this way and we keep accumulating degree day units, what happens is instead of 4 generations per year, you get 5 generations of California red scale completing. And no insecticide is going to last 5 generations. 10 years ago, growers were treating every other year for California red scale. Now growers are treating every year, and sometimes 2 times and sometimes 3 times a year for California red scale, because there are either issues with resistance, or the fact that we just have so many scales, or some insecticides aren't controlling the scale in the woods and are actually making the situation worse, like the Admire, the imidacloprid. So we've got basically a perfect storm of problems between heat and dust and only moderate efficacy of the insecticides, and then some disruption of the natural enemies. And so we have a lot of red scale. And so everyone's been wrestling with what to do about that. And one of the things that many growers are adopting is using mating disruption. There are these dispensers that you can hang in the trees, 180 per acre, which usually equates to about 1 to 2 per tree, deployed at the beginning of the season. And this is work that it was done by Joel Leonard, a master's student from Cal Poly, and he will be publishing this soon, so I won't be posting these data, but I'm going to show it to you today. He deployed these in 5 different orchards, and we went to huge plots, 10 to 20 acre plots, so 10 acres treated, 10 acres untreated. And he could see shutdown of the male scales pretty well. And at the end of the season, he evaluated what did the fruit look like. And in 4 out of 5 of the sites, he got more than 90% reduction in the scales on fruit. One block totally flopped. Don't always understand why, but it's probably a numbers game. If you have a lot of scale in the orchard, the males, when they emerge, only have to crawl an inch or two to get to the next female. So the disruption might not be sufficient to block them finding the females when there's a lot of females and a lot of males. So this technique works best after you've modified the population, reduced it with insecticides, and then applied the pheromone. And the combination of the two, notice in 4 out of 5 of these sites, the grower put in a Movento treatment in May. The combination of insecticide plus pheromone meant that instead of treating 3 times a year in all of the sites, some of the sites didn't receive insecticide and some only had to have 1 insecticide treatment. So it's a way to modify the population in combination with insecticides. So my recommendations for California red scale control are: hit the stage that's most sensitive, attack generations 1 or 2 when the scale population is uniform in stage. I didn't really get a chance to talk about that, but that is important. Use selective insecticides that allow natural enemies to help you. Rotate products to avoid resistance. Apply with good coverage. Most chemicals take thorough coverage in order to get the twigs, leaves, and fruit coated. Movento, you can go with less because it's a foliar systemic. Drive slowly to get that coverage, and use pheromone disruption in groves with chronic problems in combination with insecticides or a Fetus. And that is basically the end of my talk. So Cheryl, are there any questions? Oh, we've got to go on to the last couple quiz questions. Let's go for those. How many full generations of scale occur in a cool year in the San Joaquin Valley? 3, 4, or 5? Okay, 78% of you are correct, 4. And then when it's really hot, we get that extra 5th generation. Next question. How fast should you drive when spraying for red scale? Oh my goodness, the answer is on the screen. There we go. How fast should you drive when spraying for red scale? 1.5 miles per hour, 2 miles per hour, or 3 miles per hour? 85% of you are correct, 1.5 miles per hour. Why do you drive so slowly? Because if you drive faster than that, it tends to create a sheet of the leaves, and it actually blocks the spray penetrating into the center of the tree. So the slower you drive, the better. It kind of allows the leaves to shimmer and move back and forth and allows the spray to penetrate. 2 to 3 miles per hour is more useful when you're just trying to coat the outside of the tree, for example, with a thrips treatment. Next question. Which 2 insecticides do not control the scale on wood? So this is a multiple choice. I want you to give me 2 answers. Which 2 insecticides are not controlling scale on the wood, meaning the trunk of the tree and the heavy branches? Okay, it's the answer to the question, which was which 2 chemicals don't control scale on wood. The answers are Movento and Admire. So the majority of you got that. Esteem will control scale on wood. Next question. Why has scale been more difficult to control recently? Is it summer heat? Is it pesticide resistant scale? Is it Admire treatments? Or is it all of the above? Okay, all of the above is the correct answer. So we've had a perfect storm of summer heat, pesticide resistant scales, and Admire treatments, and it's just creating havoc with controlling red scale. Next question. So we have 2 more questions, and it's more just I just want information about what you're seeing out there and what you're doing. So the first question is, how many times per year on average do you treat for California red scale? And the second question is, are you using California red scale pheromone disruption in what percentage of your blocks? Okay, how many times per year do you treat for red scale? Most of you, not at all. And that could be because you're not a grower. We do have a few people who are not growers. But we do have some people treating 2 or 3 times. So, you know, it's not a majority, but it's happening. And are you using California red scale disruption in what percentage of your orchards? Most of you aren't using it, but those who are, anywhere between 25 and 100% of their orchards, they are using it. So it's happening out there. It's growing in use. And I think that's a good thing because it'll help reduce the pressure on the insecticides. Okay, that's it for our questions of you. So there's time for a few more questions if you have them.
And we do have a couple of questions that came in.
Okay.
The first one is, how does a grower know that the aphitis is healthy before release?
That's a tough one. Usually they put honey in the lid of the container. And if you get them and you keep them cool and you release them, everything should be a go. If you see a lot of dead ones in the bottom of the cup, then I would be asking the insectary what's going on and asking for help to manage them better.
And then there's another one, how to incorporate ACP sprays with California red scale.
ACP sprays in California red scale. Well, let me think about that. What would work for ACP? Movento has some effect on ACP. The insect growth regulators do not. So Movento would be a choice. Oil is effective, helps with ACP control, so that could be a treatment. And if we still had Lorsban, I would say that one was, and 7. The only chemicals in a scale spray program that wouldn't have any effect on the Asian citrus psyllid would be the insect growth regulators, the Esteem and Centaur.
And then there's another one, what exactly is a pheromone disruption?
Pheromone, oh yeah, I didn't explain it very well, did I? Pheromone disruption is basically you're putting synthetic pheromone on these dispensers and you're hanging them in all the trees. And when a male goes to try and find the female, he can't find her because there's a whole bunch of pheromone in his way. He can't find her pheromone. So the synthetic pheromone is confusing the males so that they can't find the females.
If California red scale is active in the winter now, will aphitis be as well?
Yes, it should be. But not every winter am I seeing activity. It's got to be pretty warm. In the olden days, 10 years ago, November 1, my group could pretty much guarantee that males would stop flying, crawlers would stop crawling, everything would, the females would diapause and they would just sort of shut down for the winter. And we wouldn't see activity again until March. So now with the extra heat, we're seeing activity later into November and sometimes through the winter, but not always. And yeah, so it's stretching out.
Yeah, I have one right now, actually a couple right now. First one is, does the changing cropping pattern in the valley with more almonds, walnuts, and pistachios affect California red scale in any way?
I can't off the top of my head think of any way that that's going to change things because most of the insects that are in citrus are very specific to citrus. So sometimes crops that use sulfur can have an impact, like grapes, because the sulfur dust is really hard on natural enemies. But no, I can't think of anything offhand.
Okay, and then there's another one. For those of us who only have backyard orchards, what do you think of mechanical removal of scale?
Mechanical removal, such as just washing and scrubbing. I'm not quite sure what that person means by mechanical. Maybe they need to define it a little better. If it's a backyard tree, you don't even need to remove the scale. you can just eat the fruit. And in backyards, the best way to reduce the scale population is to prune the trees so that they're nice and open and control ants, because in backyards, the ants are what are protecting the scales from natural enemies, because they don't produce honeydew, but they still protect them anyway. So reducing ants helps to improve biological control.
And there was clarification to that one, just rubbing them off.
Yeah, yeah. Any other questions?
Have timings of sprays for other pests changed in a way that affects red scale control?
Very definitely. For example, Asian citrusillid. Some of the treatments, like the winter dormant treatment, is a pyrethroid, which is very broad spectrum, and some of the other treatments are broad spectrum, is creating some red scale problems in some areas. So my general rule of thumb is we got to get the Asian citrusillid under control so that we reduce Huanglongbing disease potential. And if one broad spectrum treatment, even though it knocks out some natural enemies, wipes out the Asian citrusillid, go for it. And then what I see with citrus is if you don't spray broad spectrums too often, then the natural enemies recover pretty quickly. It's when we get into repeated applications. So bad applications and weak control of pests means more applications, which is more disruptive to natural enemies than one really strong chemical that knocks everything out and sort of restarts the system. So that's my general impression. But yes, Asian citrusillid and fuller rose beetle treatments are definitely having an impact on natural enemies.
Okay, and then there's a question, if ants were controlled in commercial orchards, how much less of a problem would California red scale be?
I don't know that it would make a huge difference. It depends on where you live. Argentine ants are very aggressive, and they're in Southern California orchards, but they're not in San Joaquin Valley orchards. San Joaquin Valley, we have the native gray ant, and it isn't nearly as aggressive, so I don't think that it needs to be managed at the same level. So it would depend on where you live and your situation. I don't have a general rule of thumb that it's going to make a huge difference in this region.
Okay, I think we've answered all of our questions. And so, Beth, I want to thank you for presenting today and thank everybody for attending.
Great. Thank you.
Thanks.